The next topic that we want to discuss will be three-phase systems. So what are they? Well, we just talked about sinusoidal voltages, circuits, AC circuits. And what we're going to do from there is triple it. So we're used to having one voltage that has some phase angle. Now we're going to have a second voltage and a third voltage, each with different phase angles. And they'll have amplitudes VA, VB, and VC. And if we make a phasor diagram, we essentially get this here on the right, where the differences in the phase angles we just define as alpha, beta, and gamma. So if the amplitudes are all equal and the differences in the phases are all equal, we have a balanced system. So there's two kinds of networks we're going to consider: the Y network and the delta network. So the Y network is also given as the letter Y, and the delta network is also given as a delta. So each have their advantages and disadvantages. With the Y network, we have three sources that are all attached with their negative terminals to this neutral line here. So you have a VA, VB, and VC, and they are given by VA of N, VB of N, VC of N, and this notation signifies that we have a connection between the line A and the neutral line. So with the delta network, a little bit different from the Y network, we lose that neutral wire, and we have kind of this triangle network where we still have our lines A, B, and C, but now we have voltages between A and B, between B and C, and between C and A. Notice the polarities for each voltage. So a little bit different because with the Y network, we just had A to N or B to N or C to N. Now we're actually line to line. So these are the two systems that we're going to work with. And of course, what is a new topic without new convention? So there's a positive sequence and a negative sequence. And it's a question of, in the phasor diagram, how do you label which voltage is which? So in the positive sequence, we have A, B, C, where A is going to start right here. So you would have VA, VB, and VC. And we can throw in some values for that balanced system just as some peak voltage with some phase angle. So if all the phases are equal, you have 120 degrees between all of them. Now for the negative sequence, you have this ABC, except it goes counterclockwise. Or again, we would have VA, VB, and VC. So flip from the positive sequence, but luckily these are the only two conventions that we really have to care about. Now we can also have three-phase loads. Again, we have a Y network and we have a delta network. So similarly with the sources, for the Y network, you have impedances from each line to the neutral wire, and for the delta network, they are from line to line. Now it's a little bit confusing for the delta network because you'll notice the impedance between A and B. We call that Z sub C. Now if we have a balanced load where Z1 is equal to Z2, which is equal to Z3, commonly just called ZY, and similarly for the delta network, we would just call it Z delta. Now looking into what we might see for a circuit analysis, circuit might look something like this, where you have all of your voltages, you have all of your loads, and then you get these ZL terms, which are your line impedances. And then of course you have your neutral wire right there. And this kind of sets the preface for what we're going to be solving. Now this is the Y to Y network. You can also have delta to delta networks. You can have Y to delta networks, and you can have delta to Y networks.